Hi, this is my project 2 for electromechanical systems. So starting off with the buffer part of this project, when our logic gate says that our input is 0, our output would be 0. And when our input is 1, our output would be 1, meaning that if our gate is closed, all of the current will flow and the LED will turn on. If it is open, the current will not flow and then it'll obviously be turned off, as you can see in this video. So now for the not part of this project, as you can see in the logic gate, when our input is 0, our output would be 1. And when our input is 1, it'll be the other way around. So now our output would be 0. So as you can see, looking at the diagram, when our gate is closed, our LED light will turn off. And when our gate is open, our LED light will be turned on. So technically, as you can see in the video that I'm going to show you right now, the LED light is always on when our gate is open. And when our gate is closed, our LED turns off, meaning that when you click the button, our LED light will be turned off. Now with our AND gate, we're gonna go ahead and see first our logic table. So for A and B, we would be looking at our inputs and Z would be our output. So for the AND gate, in order for the output to be 1, both A and B need to be 1. So as you can see in this table, when A and B are 0, obviously our output is going to be 0. When only one, so A or B is 1, obviously our output is also going to be 0 due to the fact that we need both inputs to be 1 in order for our AND product to be 1. So AND. So A and B need to be 1 in order for our output to be 1. So as you can see, we need to click both of our buttons in order for the current path to be closed. So both gates need to be closed in order for all the current to flow for our LED to work. And this is just the visual representation on how the circuit diagram works. You could see the upper gate and then you could see the lower gate. And in order for all of the current to flow, just as I said, both gates need to be closed to open path for all of the current and our LED to turn on. Because if one of them is open, the LED will not turn on. And this is the video on how the AND gate works physically on the board. So finally, looking at our OR gate, as the same word OR says it, we would need one input to be closed or the other one to be closed in order for our output to be 1. So for our first row, as you can see, both inputs are 0. So that would mean that our output would be 0 since none of them is actually closed. So for our second row, you can see that our B input is closed. So that would mean that one or the other is closed. So that would mean that our output would be 1. And then it would be the same thing for the third row. It's just that A now is closed and now B is open. But we just need one or the other to be closed in order for our output to be 1. And then for the last row, since both of them are closed, that would mean that it satisfies one or the other. In this case, both of them. So our output would be 1. And then this is the visual diagram on how the circuit looks like. And the following video shows how it satisfies the condition in which one or the other button needs to be clicked on, or it could also be both in order for the LED light to turn on. Thank you.